Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be continuing on with the geometry section for Meet 2, and it's actually the last video in the geometry section for Meet 2, so let's get right to it. So the first thing that we need to talk about is area. In Geometry Meet 2, there are two big topics, and those are perimeter and area. Last time we talked about perimeter, which was how long the outside of a polygon is. Now we're going to talk about area, which is how large the inside of a polygon is. So unfortunately, in order to find the area of different shapes, you are going to have to just memorize a bunch of different formulas. But as I go through these formulas, I'll do my best to explain why each formula works, because that seems to help stick it to memory a little bit better. So we'll start with the easiest formula for area, which is the area of a rectangle. So a rectangle is any any polygon that has four sides and exactly four right angles. So this would be a rectangle because it has four right angles and has exactly four sides, and is also a polygon, which means it's a closed figure with all straight sides. So in order to find the area of a rectangle, it's A equals BH. So B times H would be your area, where B is the base, which is the bottom side, and H is the height, which is it's just the height of the shape. Now, a lot of people also say length times width. So if I were to label it for you, then I guess this would be the length, and this would be the width, which we label as L and W. But for the purposes of other shapes, we tend to label them with B and H, because especially when you get to three-dimensional shapes, B stands for base, which is how large the entire bottom is. So you wouldn't necessarily say width. So that's why we also assign this to two-dimensional figures. So B will be your base, which is how big your bottom side is. And then H will be your height, which is pretty easy to see. So in order to find the area of a rectangle, you just need to multiply the base by the height. And this is the simplest formula because it's just imagine this was a 2x1 rectangle. Well, if your length was 2 here, and your length was 1, or your height was 1 here, then you would say it is 2 square units, because 2 times 1 is 2. And you kind of just divide it up like this, and you can kind of tell that this turns into 2 square units if you divide it into little chunks or square units based off your height and base. So the next formula you need to know is the area of a triangle, which is a little bit more complicated, but not actually that much more difficult to remember. So the area of a triangle is 1/2 BH. So you have your base, which again is the bottom, and you have your height, which is the height of the entire triangle. Now, it is important to note that this is not the height. So this side right here does not count as the height. This is what we call a slant height. The slant height is going to be bigger than your actual height of the triangle. So if you had a question where they asked you to find the area of the triangle, and they gave you this height as say 5, and they gave you this one as 4, and then they gave you the base as 10, the area of the triangle would not be 25. And 25 is 5 times 10, which you might think 5 is your height, and then times 1/2. The area would be 20, because the 4 is your actual height. And this number is irrelevant in finding the area of the triangle, as long as you know the base and the height. So now to explain why this formula works. It's because it's basically the same formula as a rectangle, as you might notice, except it's multiplied by 1/2. And here's why. Because if I drew some lines just like this, so I drew a line here, I drew a line here, doing my best just to make these right angles, and I drew a line here, what you might notice is that these lines turn this into a rectangle, where it has the exact same base, it has the exact same height, and I did my best to make it the same height here, but it's not the exact same area. And in fact, it's exactly half the area of a rectangle with the exact same base and the exact same height. Because as you'll notice, this line divides it in half, and then these diagonals, which go all the way across, divide each of these in half. So half of this side is part of the triangle, and half of this side is part of the triangle, which means half of the entire area of this bigger rectangle that I created, which has the same base and height as this triangle, is actually in the area of a triangle, which is why we multiply it by 1/2. It's essentially like you're finding the area of a rectangle with the same base and height as the triangle, but the triangle will always have half the area of that rectangle. So the next formula that you need to know is the formula to find the area of a square, which is s squared if s is the length of one of your sides. So again, this one's pretty simple, and here's why. Because a square is just a rectangle. By definition, a square is a polygon with 4 equal sides and only 4 sides and 4 right angles. And a rectangle is a polygon with 4 sides and only 4 sides and 4 right angles, which means that a square is a rectangle. So if you know what the base and height are and multiply it by each other, then that will give you the area, considering it's a rectangle. But you don't even need to know what any of the sides are except for one of them, which we call a side. Because in a square, all of the sides have the exact same length. So your base and height will be the exact same, which means you can just multiply s by itself, which is the length of a side. And this is what this means. Side square means s times s, and that will give you the area of a square. So there are actually 2 more area formulas that we need to know. And these 2 are the more complicated ones because they're not as easy to understand. And actually, this one is the most complicated of the ones that you need to know. So, and that's the area of a trapezoid. So a trapezoid is any quadrilateral, and a quadrilateral is any polygon with 4 sides. And so a trapezoid is any quadrilateral with one set of parallel sides exactly. So this would be a trapezoid because it has one set of parallel sides, which are labeled as A and B. And if you don't know what parallel means, it means that if we extend these sides, A and B, on and they run on forever, like this, they're never going to touch each other. They run parallel to each other, just like this. No matter how far they go on, they're never going to cross. That's what makes 2 sides parallel. And so this would be a trapezoid because these 2 sides, A and B, are parallel to each other. So the area of a trapezoid is 1/2 A plus B times H. So this differs from the other area formulas that you have because now you have 2 bases that are different, A and B. These are both technically considered bases because you have one here, and they're both completely horizontal. Now, if you have a rectangle, say, like this, you do have 2 bases, but the reason we just multiply B times H is because if, say, this base was 5, the top one, then that means that the bottom one would automatically also be 5 because opposite sides of rectangles are equal. But with a trapezoid, opposite sides are not equal, and we have to take that into account in this formula. So now this is the most complicated formula that you need to know. So I'll do my best to explain why it works to help you remember it. But I'm sorry if my explanation is a little bit confusing, but just stick with me. So the reason why this works is because we can divide it into 2 triangles and find the area based off that. So let me show you what I mean. Say I connected this corner to this corner of the trapezoid. This is what we call a diagonal, when you connect 2 corners of one shape and it runs across the shape. So I just created a diagonal in this trapezoid, right? And it's connecting this corner and this corner here. Now what I've done is I've split this trapezoid into 2 different triangles. One that's right here and one that's right here. If you remember, in order to find the area of a triangle, you do 1/2 B times H. So in this triangle, this one right here, let's shade it in a little bit, A is my base because that's how long it is across. In my height, well, my height is just like that, right? Because remember, this is not the height, and this is where it gets tricky. This is called the slant height, but this is the actual height of the triangle because it runs from the top of the triangle to the bottom of the triangle. So that's how this is the height of this triangle. Now this height is also the exact same as this height here. Because think about it, if this is parallel, that means if we just extend these lines here, then this height will be the exact same from top to bottom. So remember, the distance in between 2 parallel lines, which are A and B, do not change. So let me actually erase some of this stuff so you can see it a little bit better. So this height is the exact same height as H. So if we're to try to find the area of this triangle, we would do 1/2 times A, which is our base, times h, because h is our height of this triangle. Now, to find the area of our second triangle, we do the exact same thing. We take the base, which is b, our other base of our trapezoid as a whole, and we multiply that by the height, which is this h, and then we multiply that by 1/2. So that gives us 1/2 times b times h. So now, all we need to do is figure out, well, if we have the area of this one, which is half a times h, and this one, which is half b times h, we can actually simplify that into one whole figure in one formula where you do 1/2 times just the bases added together, a plus b, then times h. And then just to prove that this works, I'll give you an example of different types, of different values for the side lengths of this trapezoid, and actually do out the math to show you that it gives you the same result. So I'm going to pretend here that our height is 5, A is 6, and B is 10. So if I were to find the area of this triangle, remember it's 6, which is my base, times 5, which is my height, which is this right here, then times 1/2. So 6 times 5 equals 30. And then if I divide my 30 by 2, because I'm multiplying it by 1/2, then that would leave me with 15. So the area of this triangle would be 15. And then here I can do the same thing. 5 times 10, because 10 is our base and 5 is our height, is 50. And then I need to divide that by 2 because I'm multiplying by 1/2. So times 1/2. And then that gives me 25. So the area of this triangle would be 25. And if I add 25 and 15 together to give me the entire area of this entire shape, that gives me 40. Now, if I were to use my formula, 1/2 a plus b times h, then it would give me 1/2 times, and then a is 6, plus 10, and then times h, which is 5. Well, first I'm going to simplify 6 plus 10, which is 16. And then I'll multiply that by 1/2. So 1/2 times that, and that gives me 8, because 1/2 of 16 is 8. And then I still need to multiply by 5, which is my height. And 8 times 5 also gives me 40, which, if you remember, is the exact same area of the trapezoid as when I did it into 2 different triangles. So that explanation might have been confusing, but that's the exact reason why this formula works. Sorry if I didn't do a great job explaining it. It's probably the most difficult shape, or most difficult quadrilateral to explain in terms of the ones that you need to know, especially. But I guess now we'll just move on to the next shape. So the next shape that you need to know the area formula for is the parallelogram. So a parallelogram is any quadrilateral with 2 sets of parallel sides. And that's the difference between the trapezoid. The trapezoid has exactly 1 set. The parallelogram has 2 sets. So the parallelogram here has 2 sets of parallel sides, because if you'll notice, this side right here and this side are parallel. So if they extended on forever, they would never touch each other. And then this side and this side are also parallel. And if those extended on forever, they would never touch each other. So the area of a parallelogram is just b times h, which may be confusing because you remember that that's the area of a rectangle as well. But if we look at how we can cut up this parallelogram, just like we did with the trapezoid, and turn it into different shapes, you'll see why it's actually the exact same formula. So say I took this section of the parallelogram. So see where my dotted line for h is, the height, and I cut this triangle off. So imagine it's not here anymore. And then I took that exact triangle and moved it here and drew it out right there. So say I just moved this section of the parallelogram here. It's still going to have the exact same area because I cut off a certain amount and I moved that same certain amount to the different side. But now essentially what I've done is I've turned this parallelogram into a rectangle. And it's this rectangle right here. Right? Because I still have this part, I still have this triangle, which I moved from here. So now this rectangle has the exact same height and the exact same base, which is this section. Oops, let me undo that. Which is this section plus this section, and then this section was just moved over here as the actual parallelogram and as the exact same height. So if you multiply those by each other, it's essentially like finding the area of a rectangle with the exact same base and same height, except it just has a different shape. So that's why the area of a parallelogram is b times h. So now we'll try a review question regarding the area of different shapes. If you want to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. So the correct answer to this question was 100 centimeters squared. So when I read the question, it says, what is the area of the shaded region of the below shape? So the shaded region is right here and right here. So I need to find the area of those different regions. And so you might be thinking, oh, well, all I need to do is I notice that this one's a trapezoid and this one's a trapezoid. So I just need to find the area of these two different trapezoids and then add them together. Well, yes, but there's actually more of an efficient way to do it. And here's why. Because if you'll notice, this entire thing is just one big rectangle. Oops, that's not what I want to do. Sorry, if you'll notice that this entire thing is just one big rectangle like this. So if I find the area of this big rectangle, and then I take this trapezoid, which is in the middle, like right here, and I subtract this area from it, then that just leaves me with the shaded regions, because this trapezoid is the only area of this big rectangle that isn't shaded in. So the first thing I need to do then is find the area of my big rectangle. So if I find the area of my big rectangle, remember the area of a rectangle is just b times h, that gives me 200 centimeters. Because my height, my h, is right here, which is 10, which is the distance from the top to the bottom. And then my base, which is already nicely drawn out for me here, is 20 centimeters long. So 20 times 10 will give me my area of my big rectangle, and that leaves me with 200. So now all I have to do is find the area of my trapezoid here and subtract that from the area of my rectangle. Well, I need to write out the area of trapezoid formula first. So A, which is area, equals 1/2 times A plus B, because A and B are my two different bases, and then times H. So now that I know that, I just need to put A, B, and H in my formula, and I'll be all set. Well, H is just this right here. Let me draw out the line. H is just this length right here, which is my height. And that height is 10 centimeters, because if this height is 10 centimeters here, then since this is just like another side on a rectangle that I form here, like that, then that means this is also 10. So 10 is my height, so I'll cross this off, and here I'll write 10. So now my A and B are already conveniently labeled on the diagram. They're 9, which is A, and 11, which is B, as the length of my bottom base and my top base. So now all I need to do is put those in my formula. A is 9, then plus B, which is 11. And now I can just solve for A of the area of the trapezoid. So let me rewrite my formula with the actual proper values in it. So A equals 1/2 times 9 plus 11, which actually right from here, I'm just going to simplify that to 20, because 9 plus 11, which is right there, simplifies to 20. So 1/2 times 20 times 10. So first I'll do my 1/2 times 20 first. 1/2 of 20 is 10. So if I cross this out and write a 10, now the area of my trapezoid is just 10 times 10. And then 10 times 10 leaves me with 100 centimeters squared. And so now all I have to do is subtract this area of this trapezoid that isn't shaded in from the area of the rectangle, and that'll give me the area of the remaining shaded parts. So if I just do 200, which is the total area of my rectangle, minus the 100 centimeters squared of area that isn't shaded in that trapezoid, that leaves me with 100 centimeters squared of area that is shaded in as my final answer. And then just a note on IMLEM questions, you don't actually have to label it with a unit. They just expect the actual number to be your answer. Before I move on, just to note, you will need to know at least a little bit of basic algebra in order to understand what I'm going to be doing with these formulas when you use the area of a shape to find the perimeter of a shape. Now, if you don't know basic algebra, then I would recommend watching my first video on the algebra section from Meet 1, which will teach you all that you need to know to understand exactly what I'm doing here. But if you do know the basics of algebra, you can just disregard what I said and continue watching. And then finally, the last subject of Geometry Meet 2 is where the two big subjects, area and perimeter, come into play together, where you have to use the area of a shape to find the perimeter of a shape. So an example of a type of question like this would be, what is the perimeter of the trapezoid if the area is 14 centimeters squared? And then here is the trapezoid down here. So it gives you the area, it gives you some side lengths and some extra length as well, and it expects you to be able to find the perimeter of the entire shape, which is all the sides added together. So I find that the best way to explain this concept is to go through a practice question, so you can actually learn what you need to do to find the perimeter. So if you remember, perimeter is just the sum of all the lengths of the different sides. So I have my side here, which is 5. I have my side here, which is 5. So if I add this side, which I'm going to label with a question mark because I need to know it, and this side, plus 5 plus 5, then that is going to give me my perimeter. So my priority should be to find the lengths of these sides, or to find the sum of the lengths of these sides as well. So the first thing I need to do is I need to use my area in order to find this. So let me write out my area formula. So A, and then this is for a trapezoid because we're dealing with the trapezoid here. So A equals 1/2 times A plus B, which are our two bases, and we don't know the length of either of them, and then times H. So this is where it gets a little bit tricky. So the first thing you want to do with this formula is you want to put in the values that you already know. So pretend you're solving for whatever you need to solve for, and this is always your first step. You put in values that you already know. So I know my area is 14 because it says it in the question. So that's going to be equal to 1/2 times A plus B, which I don't know the value of either of them, and then times H, which is 4, because it gives me right here that the height of this trapezoid is 4. It's not 5, because 5 is the slant height, so my height is 4. So now I can put this in the equation. So right here, what you want to do is you need to find the values of A and B. Well, this formula solves for A, as in the area of the shape, instead of A and B, which are the two bases. So the way that you would solve for A and B is just like you would solve for any other variables in an algebra equation. So I want to find A and B, so I need to isolate them on one side of the equation by moving everything else to the other side. So the first thing I need to do is multiply 14 by 2. Because if I'm getting rid of this 1/2, then I need to multiply by 2 to get rid of it. And so this is where it gets a little bit complicated. When you multiply something by 1/2, it means you're dividing that number by 2. And so in order to get rid of this 1/2, I need to do the opposite operation of division by 2, which is multiplying by 2. So if I multiply this side by 2, and then multiply this side by 2, remember this dot means multiplication, and this leaves me with 28. And then that's going to be equal to 1/2 times 2, which is 1, because they cancel each other out. So 28 equals A plus B times 4. So now, in order to get A plus B on the side on its own, and then the reason you can do this is because this is in parentheses, which means imagine that A plus B is just some number. You always just have to do this first, which means you can just regard it as like one singular number that you're dealing with, like one variable essentially. So you need to divide by 4 because you need to get rid of this multiply by 4. And the opposite operation of multiplication is division. So if I divide both sides by 4 like this, so divided by 4, and then do 28 divided by 4 as well. 28 divided by 4 is 7. And then these two cancel out because times 4 divided by 4 just leaves me with 1. So 7 equals A plus B. So now I have a little bit of a dilemma because I know A plus B equals 7, right? And in order to find the perimeter of a shape, you need to add all the different side lengths. So I need to add A plus 5 plus B plus 5. And so this is where a lot of students get really stuck because they're really, really close to the answer. And they think, oh, I need to find the value of A and I need to find the value of B and then add them all together. So the issue with that is you don't actually need to find the individual lengths of each side. Because remember, perimeter is just the sum of all the lengths of all the sides. So if I know that the sum of these two sides are 7, then I don't need to actually find their individual lengths. As long as I know that they add up to 7, it's okay. And it's actually, well, with the measurements given, you could technically find the values of each of these sides, but it'd be really difficult and sometimes you might not get that nice numbers. So it just saves you time to know that since 7 is the sum of these two sides, you don't need to find each individual side length, but you should be content in knowing that together they add up to 7. And then you can just use that in your perimeter formula. So I have 7 as the length of these two sides together, and then I just need to add that to 5, which is this side, and 5, which is this side, and now I have all 4 sides accounted for. So if I add 5 plus 5, and then plus 7, that leaves me with 17. So finally, I have one last review question. If you'd like to give it a try, I'll give you a few seconds to pause the video, and then I'll go ahead and explain the answer. So the correct answer to this question was 56 centimeters. So the question reads, find the perimeter of the below figure if the area of the figure is 75 centimeters and the slant heights are equal. So first you need to figure out what figure this is. This is a trapezoid because right here and here, our two bases are parallel sides. So now we need to just look at what measurements that we have and figure out what measurements we need to have in order to find the area of this shape, in order to find the perimeter of the shape. So the perimeter of the shape is going to be equal to all 4 of the sides added. So we need this side, this side, this side, and then this side, and we don't actually have any of them. So the first thing we need to do is figure out what sides we can easily find. Well, we know that the slant heights are equal, so if we find the value of this side, say, then we know that it's the exact same as this side, because these are both slant heights of this trapezoid. So first, I'm going to focus on finding the length of this side, or this slant height right here. So I have 2 measurements given to me on this trapezoid. I have the height, which is 5, which is going to be useful when I find the different bases using the area formula. And then I also have this length here, which doesn't stretch the entire base of the trapezoid, but it does stretch to right here. And so they obviously gave me this length for a reason. And so the reason that they gave it to me is because if I take this height right here and I take this length, I can actually create a right triangle right here. And the reason that this is useful is because in order to find the length of this side, you have to use the Pythagorean theorem. So if you remember what the Pythagorean theorem states, it's a theorem that can be used to find the different sides of right triangles if you already know 2 of the side lengths. So the Pythagorean theorem states that a squared plus b squared, where a and b are your legs of a right triangle, equals c squared. And if you have no idea what I'm talking about, it's a formula that I explained in the previous Me Too geometry video, the first one, that allows you to find the length of different sides of a right triangle. So essentially, A and B are your 2 different side lengths, or your 2 different leg lengths right here. So A would be 5 and B would be 12. And C is the length of the longest side of the right triangle, which is what we call the hypotenuse. And this is the side we need to find. So we know what A is, we know what B is, so now we can use that to find C. So first, A squared is going to be equal to 5 squared, because A is 5, and B squared is going to be equal to 12 squared, because B is 12. And then that's still going to be equal to C squared. So now if we simplify our equation, 5 squared, which just means 5 times 5, because it's 5 times itself twice. So 5 times 5, and then plus 12 times 12, because 12 squared is 12 times 12, equals c squared. And then when we simplify these two numbers, that leaves us with 25 plus, oops, that was a bad 25. There we go. 25 plus 144, because 12 times 12 is 144, equals c squared. And then finally, we can do a little bit more simplifying on the left-hand side, which is 169, because 25 plus 144 is 169. And so that's equal to c squared, which is our hypotenuse squared. So we're not finished, because the last step that you need to do is to find the square root of both sides. So the square root of 169 and the square root of c squared. And the reason being is because the square root of c squared is just equal to c. Square root and squared are opposite operations, which are also good to remember in case you're doing some algebra stuff and you need to do some opposite operations. And so if we take the square root of c squared, then that's going to leave us with c. So now the square root of 169 gives us c. And unfortunately, again, this is something that you're going to have to memorize. If you don't know what the square root of 169 is, you're just going to have to guess and check as you do this. Well, 169 I know is 13 times 13. So the square root of 169 is 13 on its own. So 13 is the value of c. So now I know that this slant height right here is 13 centimeters long. And that means that this one also has to be 13 centimeters long, because remember, the slant heights are equal in this figure. And it tells us that in the question. So now I'm just tasked with finding the top and bottom bases, which we essentially already did. We got the area of the figure and we got the height. So now we can just do what we did before when I explained how to do these types of questions, and then we can use that to find the perimeter. So if we write out our formula to find the area of a trapezoid, which is A, and big A as representing area, equals 1/2 times A plus B, which are two sides that we don't have but we need to find. And I'll label them on the diagram for convenience. So this is A and this is B. So times A plus B, and then times H, which is our height. So A equals 1/2 times A plus B times H. So now we just need to fill in whatever we don't, whatever we have, or whatever we already know. So we already know that the area is 75 because it tells us that in the question. So 75 equals 1/2 times A plus B, and we don't know A or B, so we can't fill those in, and then times H. And we know that H is 5 centimeters because it tells us that also in the diagram. So now we have a bunch of different values, and essentially again, since we need to know what the values of A and B are, because remember our perimeter is the sum of all our side lengths, so if we know the sum of A and B, that's also fine. Then we just need to solve for A plus B, and we can consider this as like one term together. So we can solve it as if we're solving for A plus B with any of our algebra skills. So first, to get rid of this 1/2, because remember we want to isolate A plus B on its own. So we need to get rid of this 1/2. Well, 1/2 is just dividing by 2, so we just need to multiply both sides by 2. So if we do 75 times 2, remember the dot means multiplication, and then equals 1/2 times A plus B times 5 times 2, because we need to do the same thing to both sides to keep it equal. Then this 1/2 and then times 2 cancel out, because 1/2 times 2 is just 1. And so that leaves us with 2 times 75, which is 150, equals A plus B, and that doesn't change, times 5. So now our last step is to get rid of this times 5 with the A plus B. And so in order to get rid of a multiplication of 5, we do the opposite operation of the same number. We divide by 5. So if we divide both sides by 5, so divide by 5 here, divide by 5 here, well, we get 150 divided by 5 as 30. and then that equals a plus b times 5 divided by 5. And remember that times 5 and divided by 5 cancel out because that's the whole reason we're doing it. So that just leaves us with a plus b. So we know 30 is the value of a plus b together. So now that we know that, again, we don't need to find the value of each individual side, because remember, perimeter is just the sum of all the sides together. So if we know the sum of two sides, we don't need their individual values. We can just add that to the values of the other sides. So we know a and b together are 30. So I'm just going to draw an arrow and say these are 30 centimeters. So now we just need to add 30 plus 13, which is this side, plus 13, which is this side, and we have no side unaccounted for. So 30 plus 13 plus 13 equals 56. So 56 is the perimeter of this trapezoid. Now, just to quickly review what we've learned this lesson, we started out with a bunch of different formulas to find the area of different shapes, which unfortunately you do have to memorize. Now, I won't be going over exactly why they work again, just for time's sake. So the area of a rectangle is b times h, where b is our base, or what some people might call the width, and h is our height, which some people might call the length. But for the purposes of more complex shapes, we just use b and h, where b is base and h is height. So the area of a triangle is 1/2 b times h, because it's half the area of a rectangle. And then the area of a square is s squared, where s is the length of one of the sides. And then we learned two more formulas. This was the most complicated one. The area of a trapezoid is 1/2 times a plus b times h, because a trapezoid has two different bases, a and b, which are opposite each other, and they're the two parallel sides. So you add them together, multiply by the height, and then multiply that by 1/2. And then finally, the area of a parallelogram is b times h, where b again is our base and h again is our height. And then we also made an important note that this is what our slant height is, but this is what our height is. Our height is the actual height of the figure from top to bottom as a vertical line, and the slant height is the slanted height from top to bottom, except not as a vertical line. And it's important to note that you use h in your formula, and you can't use the slant height or it's going to be incorrect. And then we did a review question pertaining to different formulas for different areas of shapes. And we learned that if we found the area of this big rectangle and subtracted the area of this unshaded trapezoid, we could find the area of the shaded region that's left. And that left us with 100 centimeters squared. And then finally, we learned about how to use area to find the perimeter of different shapes, which was a little bit more algebra based and a little bit more complicated. So we learned that we need to use the formulas to find the area backwards by substituting in the area and other values that we already know, and then use algebra to simplify to find whatever values we're missing. So in this case, we had to find the value of a plus b, which is the sum of our two bases, in order to find the perimeter of the shape. And then we did one last review question using the exact same concept, except we had one extra added twist, where we also had to use the Pythagorean theorem in order to find the value of the slant heights, which were equal, and those were 13. And then when we found the values of the bases added together, we found the entire perimeter to be 56 centimeters. So that's all I have for you today, and that's actually the end of the geometry section for me too. I hope this video was helpful, and I hope I could explain some of these concepts well.